solve for x in terms of a, the solution to the equation 3x minus 7 equals ax plus 5 is, right? We're solving for x in terms of a, so we want to end up with x on one side and then everything else on the other, or even just a on the other with everything else, okay? So I rewrote the equation, and the first thing I did was get rid of the 7. I want to move the lowest constant first. So negative 7 is less than positive 5. So I add 7 to both sides, right? And I end up with 3x equals ax plus 12. Okay, from there I want to get rid of ax. I don't want to separate the a from the x. They're being multiplied, but I see that there's an x here and an x here, so I feel like I can do something with that. There is a commonality there, right? Combining like terms. So let's subtract ax from both sides. Now, we end up with ax equals, we end up with 3x minus ax equals 12. Okay, now we see here that, right, we can't just combine like terms because we don't know what 3 minus a is, right? But we are kind of combining like terms by taking out the common factor. Okay, so we take out this common factor x. So we pull it out, and we end up with x times 3 minus a. Okay, which is actually what we're, if this was a number here, we would be subtracting the coefficients, right? And that's what we are doing here. We're subtracting the coefficients, and whatever that was would be times x. And you could see even with the distributive property, we have x times 3, which would give us 3x, and x times negative a, right, would give us negative ax, okay? So now we have that this equals 12, right? Bring down the 12. And we want to get x alone. So to get x alone, right, as if this was just a regular number. We don't know what a is, but if we wanted to get x alone to get rid of this whole term, and I like to call it a phrase, I put it in parentheses so you can see that they go together. The x goes with the x, and the coefficients that are being subtracted are going together. And just like we would if it was a number, if it was a 5 or whatever it would be, we would divide it out to get x alone. So we're going to actually divide out the whole phrase on both sides. Once we do that, we could cross out 3 minus a. And when we cross that out, right, we have x equals 12 over 3 minus a. Okay. Oh, that should be 3 minus a. Where's the minus sign? Maybe. Okay, let me just erase this. 3 minus a. Okay, so that is answer 2 here. Okay, now we have a second question. So it says, what is the y-intercept of the line that passes through the points -1, 5, and 2, -1? So if we were to draw a table for a second, right, we have x and we have y values, right? Our x value here, -1, and our y value is 5. And then we have another x value of 2 and a y value of -1. Now, we can use these points. There is an equation, but in our calculator, and I mean, you're welcome to use the equation if you know it, but in our calculator, knowing that these points and they're forming a line, we're going to go to Stat Edit. A second. If you want to know how to get rid of the adds on the bottom, you just go and you click the arrow down to get rid of them. So we go to Stat Edit, enter, and we're going to put our x's and y's into stat edit x in L1 and y in L2. So for L1, we have -1, 2. So we have -1 and 2. And for y, which is L2, we have 5 and -1. And you want to make sure that the ordered pairs are together. Okay? You want to make sure that this would have been -1, 5, because you're making a table here. Okay? So now I'm going to go to stat, calculate, and you guessed it, we're going to linear regression because we want the linear equation. Okay, and here we have y equals ax plus b, where a equals -2 and b equals 3. So let me erase this, or I'll leave it there. So we end up with y equals, and our a is -2. So it's -2x plus 3. Okay, so when we look here, we know our slope-intercept form is mx plus b. So we know our b, just from saying that, is this, right? And our b is our y-intercept, okay? If we were to make x 0, y would be 3. -2 times 0, right? 3 is still left there. So our b, our y-intercept, is is 3. Okay, let's take a look at number 3. Okay, the dot plot below shows the number of goals Jessica scored in each lacrosse game. Now, you could do this a long way if you had to put in each of these values to find doing it in the calculator, but you could also see that this is the mode, right? It has the most values. The median, you're going to go and I just went 1, 1, 2, 2, 3, 3. And you could actually cross them out. I didn't do that but I don't know why. So 1, 1. I know that there's 2 coming up. I usually like to keep it more in order, but it is, if you can go and do that, that is fine. 1, 2, 3. That's my doggy. 1, 2, 3. 1, 1, 1, 1, 1, 1, 1, 1. Okay, so since it's an even number here, it falls between 2 and 3. So you would take the average of that, which would be 2 plus 3, right, which is 5, divided by 2, right? So the average would be, you add up the numbers, right? And we're going to divide that by 2. Okay. And that's going to give us 2.5. Yes, my dog is barking. She's very protective. Someone was at the door. Okay. So that's our median. Our mode is 3, and let's see our mean. So our mean, now we got 2 dogs in it. How you like that? I'm not stopping this video because I want to get it done today. So you're just going to have to be patient and listen to Roxy. She is a German Shepherd mix with Lab from Puerto Rico and maybe a little bit of Beagle. So she's very protective. Roxy. Okay. So our mean, right, if we look at this, it's pretty symmetrical. Okay. You know, it's not completely symmetrical, but you could kind of see that there is a bell shape here. Okay. That being said, our mean and our median is going to be equal. Or about equal. But I can't write out mean right now. Okay, so let's take a look at what we have here. Our mean is greater than our mode. Well, that's not true. Our mode is 3 and our mean is 2.5. Our mean is equal to our median. That is true. So, I mean, I'm just going to point out the mode and the median, right? They're not equal, and the median is not greater than the mean. It's equal to the mean. So your answer is 2. Okay. If you are not sure about that, you might want to review, right, the data plot stuff, the scatter plot, not scatter plot, the dot plots and the spread of distribution. Okay, let's take a look at number 4. The box plot below summarizes the data for the amount of snowfall in inches during the winter of 2021 for 12 locations in Western New York. What is the interquartile range? So we have here, in case you don't know, right? This is our beginning number. This is our final number, right? The highest it goes, the maximum value, minimum value, right? This is quartile 1, median, which is quartile 2, and quartile 3 here. Okay, so our interquartile range is the range between quartile 1 and 3. Okay, which from here, this is 110, and this is 60. So we have 110 minus 60, which is 50. Sorry that my handwriting is not great. Like, this is my first time using a stylus on the trackpad of my Mac, so it's a little sloppy, but we'll get through it. So solve for A over here. So just like we had with the first one where we had to manipulate the equation, we're going to do that again. So here we want to get A alone. Okay, so the first thing we're going to do is move the B to the other side of the equation. How do we do that? Well, now it's being divided, so we're going to multiply it on both sides. Okay. Give me 1 second, guys. So after I multiply it on both sides, this cancels out, and I end up with B, U, or UB, it doesn't matter which order I put it in because they're being multiplied, equals AK. Now I want to get rid of the K to get A alone. Well, A and K are being multiplied, so I'm going to divide out K. Okay, and we end up with BU over K equals A. So this is definitely slower than using my iPad, but it's also kind of easier to make the videos. So now over here, we're also solving for A. This is a little more complicated, and you could just tell because there's an A on the denominator and numerator. But we're going to move things around and see, just taking it step by step. So the first thing I want to do is get rid of the denominator. Okay. And I do that by multiplying A on both sides. All right, so I have A here, and I'm multiplying A here. So I'm going to cancel this out, and I have AG equals, that looks like a Y, right? Let me see if I could, that's good enough, equals 1 plus 2A. Now I want to get all my A's on one side, so I'm going to get rid of this 2A. Okay, I'm not going to move the other one AG because then I'm left with 0 on one side, and that would just start to get messy for no reason. So I'm going to take away 2A. Minus 2A. Minus 2A. Yes, my house is a very noisy house, but I want to make sure I get this done for you guys. So we have AG minus 2A equals 1. Now, I want you to notice, just like in that first problem we did, okay, we have an A in both terms, right? We don't know what G is, but the G and the 2, right, we could call them coefficients, okay? Because that's what we would be taking away. So we have the G amount of A's and we have -2 amount of A's, okay? So we can't combine them easily because we don't know what G is, but we can pull out the common factor and say, well, we would multiply A by combining the G and the 2. So we're multiplying A by the coefficients being combined, right? And that would give us distributive property A times G, which would give us AG, and A times -2, which is give us -2A, right? And that equals 1. Now, we want A by itself. So we want to take this phrase, right, what's being multiplied by A, and getting rid of it. This whole thing is getting multiplied out to A, is getting multiplied to A. So I'm going to divide out the whole thing. All right, and then we have 1 divided by G minus 2. And that's your answer here. Let's cross out. That's cross out. We have A equals 1 over G minus 2. So just to sum it up so you see it. 1 over G. Oh, it's the worst G in the world. Minus 2. Let's see if I can make that G a little bit better. I can't find the eraser, so We're going to leave that G as is. Okay, it's a little bit better. All right, so A equals 1 over G minus 2. Let's go to our next question. All right, the solution to 4, right, parentheses x minus 5 parentheses over 3 plus 2 equals 14. Okay, so there's a couple of different ways to go about this. I find it best to solve for x. So, right, and you are solving for x, but there's a couple of ways you could do it in your calculator, right? You can substitute the values and see if it works. If you don't know how to solve for x, that is a good way to go. First, we're going to solve for x, and then I'll show you the other way. So we have 4 times x, which is 4x, right, minus 20, because we have 4 times negative 5, over 3 plus 2 equals 14. Now, this 2 is hanging out by itself, right? It's not part of, and let me try to make it easier to see. Move it over a little bit more. Right? It's not part of that fraction. So that's the first thing I want to get rid of, right? It's like the layers. This is the top layer, right? It's not as strong. It's easy to get rid of. We're just going to move it by minusing 2 on both sides. If it was part of the fraction, we would have a different story. But in this case, it's not part of the fraction. Minus 2. So we have now 4x see. Right, we have 4x minus 20 equals 3. I mean, over 3 equals, 10. Now, this is all together. So the first thing I want to do is I want to get rid of the denominator. I don't want there to be a fraction if I could get rid of it. Okay, so I'm going to multiply, because it's being divided out, both sides by 3. And I end up with 4x minus 20 equals 30. Now, I am going to add 20 to both sides. Sorry, this should be 12, not 10. I'm like, why doesn't this make sense? Okay. All right, so this is in 30. It should be 12 times 3, which is 36. I'm just going to turn that into a 6. Why am I going crazy? Right? So I hope you understand that. I subtracted 14 minus 2, and before I got 10, which was wrong. It's 12. I don't know what I was thinking, but okay. So we have 12 times 3, which is 36. So we have 4x minus 20 equals 36, and I'm going to add 20 to both sides. Now we have 4x equals, put my x in. Sometimes this is just difficult to do. Equals 56. Now we need to get rid of the 4 by dividing, right? 56 divided by 4 and 4x divided by 4. Okay, and we would end up with 14 as x. 56 divided by 4 is 14. Now, if you don't know that, I know it's not. I actually, I had to think about it because, um, you know, thinking about 56 divided by 4, it can't be 15. I know it's got to be greater than 10, right? Because 4 times 10 is 40. So it's got to be one of these, right? And it's not 15 because 15 times 4 is easy to do. It's 60. So it has to be 14. Or you could just do it the long way of, 4 times 10 is 40 plus 16, which is 4 times 4. So you would get 56. Okay. Now, here's another way you can do this. If you're like, I have no idea how to do this, right? Let's make it a... Okay, just clean it up so it's not so much here. All right, so I'm going to do it with, I'm going to start with 15 because that's the first answer. And I'm going to put x as 15 in here. So I'm going to go 15, store x, enter. Okay, now that I have my x equals 15, I'm going to put in this equation, right? I'm going to go alpha y equals to make a fraction. And this equation is 4 times x minus 5 over 3 plus 2, okay? And that should equal 14. If it doesn't equal 14, then it's not correct. And it doesn't. It equals 46 over 3. Okay? No matter what that is, it's not 14. It's not a whole number. Okay, so to find out a different one, I'm going to use 14, right? So now I'm going to do 4. Maybe I did this wrong. X. No, 14 still x. And I'm storing x as 14. So now I'm going to go up and just highlight this equation and hit enter. So I copy and pasted it. But x for this one is 14 because I told the calculator now all x's are 14. And I hit enter and I get 14. And that's the answer I want to get. Okay, so I know that it is number 2. Okay, either way works. If you can't remember how to solve an equation or what to move first, because I know sometimes it's difficult to find which term am I moving first when there's so many terms going on over here and phrases, right? This is a valid way to figure it out. Okay, you could also do it the long way of substituting it in and solving, right? You could have made that 14 and then did all of the arithmetic. That's up to you. Okay, so let's take a look at the next question. A tour bus can seat at most 48 passengers. An adult ticket costs $18 and a child ticket costs $12. The bus company must collect at least $650 to make a profit. If A represents the number of adult tickets sold and C represents the number of child tickets sold, which system of inequalities models the situation if they make a profit? So there's 48 seats altogether. It could seat at most 48 passengers, right? At most. I love this is a clue word. At most means it has to be either less than or equal to. Okay? It can seat 48 passengers or anyone less than that. An adult ticket costs, so we have A and C here. Let me see. A represents the number of adult tickets and C represents the number of child tickets. That's going to be important to me when I'm putting costs and seats together, knowing what I'm doing. Okay, so an adult ticket costs $18. So I know A, right, that's the number of adult tickets, is going to be times 18. Or let me say 18A. That's what we're used to seeing. So we have 18A, okay, and child seats, so plus 12C. This is the cost, a number of tickets. And we see the bus company must collect at least. So at least is greater than or equal to. So we have greater than or equal to $6.50. So I'm going to rewrite this neater so that it's easier to see. Okay, and we have 18A plus 12C, okay, is greater than or equal to $6.50, right? Because it says it wants to make a profit. It wants to sell of at least, okay? So how much money they make is going to be that. Now, we know that there are adult seats and child seats. So we know we're going to have, right, A plus C, however many number of adult seats plus how many number of child seats. And they're going to be, right, we're talking about passengers, the number of seats. It's going to be less than or equal to, okay, 48. All right. All I did was take the information they gave me and I translated it to an equation. It's almost like if I was to just write this in instead, a tour bus can seat at a tour bus, right? And put this in, can seat at most this, and then this is the profit I want to make. Like, it's really just a translation of it, right? Now, I put the number of tickets and the cost together with where money goes. And then I just put the number of seats, sorry, not ticket seats, no tickets sold. The number of adult tickets sold plus child sold should equal all the tickets all together should be 48 because there's only 48 seats, or it should be less than or equal to 48. Okay, so which one gives me that? Well, this doesn't even have an equal sign on the first one. So it's not this. Okay, this is not, it's not this. All right, so now over here, we just have to know which way the signs are going. So this is less than or equal to 48. Wow, so now we really just have to know this sign. And this sign should be greater than or equal to, because we want to make a profit, right, of at least. Okay, at least means we want that or more. Okay, so let's take a look at number 8. During summer vacations, Ben decides to sell hot dogs and pretzels on a food cart in Manhattan. It costs Ben 50 cents for each hot dog and 40 cents for each pretzel. He has only 100 to spend each day on hot dogs and pretzels. He wants to sell at least 200 items each day. If H is the number of hot dogs and P is the number of pretzels, which inequality would be a systems of inequalities used to determine the total number of hot dogs and pretzels Ben sells. So, during summer vacation, Ben decides to sell hot dogs and pretzels on a food cart in Manhattan. It costs 50 cents for each hot dog and 40 cents for each pretzel. He only has 100 to spend each day. So I'm going to tell you that the prices, right? Like hot dogs are 50 cents, right? So it's 0.50. H, I'm going to make sure you can see that decimal, plus, actually, I'm just going to copy and paste this here so that we can see. Ooh. can move it down. All right, and I'm actually going to change it up to 0.50 H plus 0.40 P for pretzel. And get rid of this. Okay. And we have, okay, he only has 100 to spend, so he can't spend greater than that. So it has to be less than, and he can spend 100, so it has to be less than or equal to 100. Okay, so that's one equation, which we don't see here at all. So let's take a look, because this has to do with money. So we want money, right? When we're talking about the amount it costs for hot dogs and amount for pretzels, right? And we're talking about $100, right? That goes together. Now, our next equation that we can have is the number of items. So we'll have hot dogs plus pretzels, right? And this says he wants to sell at least 200. At least means either 200 or more than 200. So greater than or equal to 200. Okay. Now, this is H plus P. We know that it can't be. We know that it can't be 3 or 4, because when we're talking about the money, we're not talking about 200. We're talking about 100. So we have to take a look at these. And H plus P is greater than or equal to 200. So it has to be number 2. So I know it's a lot to do all this reading, and if you struggle with it, maybe you want to save the longer questions like this for last, so you do what you can easier and then go back to them. Like if you just read it and you feel like you don't know what it is, and if you take a guess, that's fine, but when you are done with everything at the end, you would want to go back and just look over it, right? You want to go back and see how you can do it, so you don't have to worry about being stressed about it, okay? At Berkeley Central High School, a survey was conducted to see if students preferred cheeseburgers, pizza, or hot dogs for lunch. The results of this survey are shown in the table below. So we have cheeseburgers, pizzas, hot dogs, and females and males. Okay, it's a two-way table. Based on this survey, what % of students preferred pizza? So this is of all the students. So our total students, we're going to add up. These are students here. So our total for the row is going to be 32 plus 40 plus 24. I'm going to use a calculator to not mess that up. So we have 32 plus 40. Wait, let me see. Plus 44 plus, let me make sure I did this right, 32 plus 24. And that's 100. Did it tell us how many? No, it didn't. So we have 100 here, 100 females. There's all different ways you could have done this. You're just adding all the numbers together. I just did it in rows because it's easier. Okay, 36 plus 30 plus 34. And that equals 100. So essentially, right, 100 plus 100 is 200. So our total is 200. You don't have to just do it by row. You're just adding everything together. You're adding all of it together and you get 200. So you know the total amount of people that were participating in this was 200. And it asks what % of students preferred pizza. So now you want the total number of students that preferred pizza. Okay, it's not asking about females or males. It's asking for out of the total and how many of all the students like pizza. So over here we have 44 plus 30, which is 74. So out of 200 students, 74 preferred pizza. Now we know it's definitely not 74% because it's out of 200. So we have 74 divided by 200. and that equals 0.37. And to turn this decimal into a percent, we just move it over 2 places. And so it's 37%, right? Or you multiply it by 100. Okay, so the table below shows the time in hours spent by students on electric devices in their math and their math test scores. The data collected model a linear regression. Okay, what is the correlation coefficient to the nearest tenth for these data? Okay. Wow, such a weird way to word stuff. Okay, so what I'm going to do to find the correlation coefficient is I'm going to put these numbers in to my my stat calculator. So I'm going to go to stat edit and I am going to clear line 1 and clear line 2. Now, line 1, I have 3. Let me see if I can move this over so I can see it at the same time. So I have 3, 1, 4, 0, 3, 7, 5, 2. Okay, then I have 85 in line 2, 99, 81, okay, 98, 90, 65, 78, and 90. Now I'm going to go to stat again and hit calculate linear regression. Now, when I do that, I don't see the correlation coefficient. Okay, because you need to go to mode and make sure stat diagnostic is on. So you're going to go down to stat diagnostic and see over here it's off. I want to move it over so on is blinking and hit enter, and now it's on. Now I'm going to go back to stat, calculate, linear regression, and now my R is here. Okay, so my correlation coefficient is represented by the letter R here, and we have it as negative 0.97. So 0.977. So to the nearest tenth would be negative 9.8, right? Because the 7 makes it go up. Now, if you didn't know how to do the mode, right, how to change the mode for stat diagnostic, you could use negative 4.8 to make an educated guess on if it's negative or positive, okay? And then from there, you would make a guess. You really wouldn't have a choice. If you don't have the R, you have to try to use what you have, okay? And all you know is the slope is negative, so whatever the correlation coefficient is going to be, it's going to be negative, okay? You really should practice, though, setting your calculator up so that you can solve this problem. And it really is practicing with it, because the calculator is like any other instrument. The more you do something, the more you know how to do it. Okay, so let's take a look at the next question. Which systems of equations has the same solution as the system below? Okay, now there's a couple of different ways you can do this. You can use graphing, and you can also solve them and see. So first thing I want to do is see how I can eliminate something here. Okay, so I'm going to multiply this by 3. The top by 3. And I have 9x minus 3y equals, this is 21. Now, this is not going to be that one, because this is not negative and this is not negative. Okay, so let's try a different way. What if we were to multiply this top one by -2? Okay, so take a look at this and we see, okay, we can multiply that by -2. How do I know that? Well, I see that -2x times 3 is -6x. -2x times -y. Or actually, let's do it +2. Okay, so we have 6x, then we have -2y, and it's equal to 14. So that is true. Okay, now we have this side, and we know that it's going to be -6x. So -3, I'm going to multiply it by to get -6x, right? So this is -6x, -3 times +3 is -9, so this is already gone. I know this is also not right. Okay, now let me erase this and do some more calculations and work. Okay, so how would I make 18x and -6y equals 42? I would multiply it by 6. So if I multiply this by 6, I have 6 times 3x, which is 18x. 6 times -y, which is -6y. 6 times 7, which is 42. Okay, so this checks out. Now, if I multiply this times 2, because I look at the 2x and I see 4, and I know 2 times 2x equals 4x, so I'm going to go with 2. Okay, so 2 times 2x is 4x, 2 times 3y is 6y, and 2 times 12 is 24, so they both check out. So it has to be this one. Now, I know it seems weird because I wasn't solving for anything. I just had to find out which one would have an equivalent solution. And so when I did multiply the equation, I multiplied each, like this whole equation by a constant, and I multiplied this whole equation by a constant, so it kept the equations the same. Okay, doing that, right, the solutions are going to be the same, because if the equations end up being the same as they were, right, their slopes, it's going to be the same equation. Okay, so let's go to number 12. Given the following data set, right, which representations are correct for this data set? So taking a quick look, I see 70 is the mode. So this is looking like it can be 2, 3, 1, 2, 1, 80. All right. So looking for the median. 1, 3. This is just how I do it. Like sometimes I'll do 3 at a time, but if I do, you have to keep track of it. So the median is 80. So that is true. And then this one shows frequency. So this is between 61 and 71. So 1, 2, 3, 4, 5. So that's up to 5. That's correct. 71 through 81, which is 3. That looks correct. And 81 through 91, which 1, 2, 3. Okay. And then 91 through 100 is 4, and that's about lower. So this is correct. Okay. So the only one here that has 1, 2, and 3 correct is 4. So that is your answer.